Programming is all about solving problems and building solutions. But as project grows larger and more complex, managing them can become challenging. That's where object-oriented programming comes in. OOP is a powerful paradigm that helps organize and structure code. To understand it, imagine you're designing a car. Every part is like the engine, tires, and seats has its own job but works together to make the car run smoothly. Now, if you decide to upgrade the engine or add a sunroof, you don't have to rebuild the entire car. You just focus on the part that needs changing. So that's exactly how OOPs work. It lets you split the big problem into smaller pieces so you can reuse, update, or improve your code without starting from the scratch. So in this video, we will discuss various concepts of OOPs. We will start with understanding inheritance in Java. After that, we will cover polymorphism in Java, and then we will learn about encapsulation, and at last, we will understand abstraction. Classes and objects are already covered. So, we will cover all these concepts in OOPs and their types with hands-on examples. Now, before we begin, make sure to subscribe to the channel and hit the bell icon to never miss any update. So now, without any further ado, let's start with the first concept, which is object-oriented programming in Java. So OOP is based on 4 fundamental principles that form the foundation of its structure and design. These principles provide a framework for creating modular, reusable, and maintainable code. So these 4 principles are inheritance, polymorphism, encapsulation, and abstraction. Alright, now let's move on and understand these concepts one by one. So first one is inheritance. Inheritance in Java is a mechanism where a new class called the child class acquires the properties and behaviors of an existing class known as the parent class. Now in simple terms, inheritance allows one class to reuse the code from another class. The child class can also add its own unique properties and behaviors or modify the inherited ones. For example, imagine you have a class that represents a generic animal. Now, if you want to create a class for specific animals like a dog or a cat, instead of writing all the properties and methods from scratch, you can inherit those properties and methods from the generic animal class, which is the parent of both these classes.
So inheritance. Inheritance in Java is a mechanism where a new class called the child class or subclass acquires the properties and behaviors of an existing class called the parent. You can also call parent class a superclass. Now in simple terms, inheritance allows one class to reuse the code from another class. The child class can also add its own unique properties and behaviors to modify the inherited ones. You can assume it as a child which inherits properties from its parents, for example car, scooty, bikes, and houses also. So that child is inheriting the property from its parent. It is similar to that. To put it in easy words, I can say, imagine you have a class that represents a generic animal. Now if you want to create a class of specific animals like dog or a cat, instead of writing all the properties and methods from scratch, you can inherit those properties and methods from the generic animal class, which is the parent class of both. All right. Now the question is how to use inheritance in Java. So here's how the inheritance works in Java. Firstly, you have to focus on the parent class. So this is the class that will be inherited from. It's like a general class that has common features. All right. Then comes the child class. So this child class inherits the features of the parent class, as I told you. Now the child class can add more features or change existing ones. For example, you're a child of your parent. Now you inherit the scooty or car from your parents, right? But you can also buy your scooty or bikes or cars. So that property is yours and your parent property is also yours. So that's what we are talking about right now. So the child class is inheriting the properties of its parent class, plus the child class can add more properties and features or change the existing ones. All right. Now to make one class inherit from another class in Java, we use the extend keyword. So as you can see on the screen, mammal is the parent class and dog is the child class. And this extend keyword is used when we we have to show that this is the parent class and this is inheriting the property of the parent class. For example, to make one class inherit from another, for example dog is inheriting the properties of mammal, so we use dog extends mammal, like that. All right, this is the basic syntax of it. So in this example, the dog class is created by inheriting the properties and behavior of the mammal class. Here dog is the child class and mammal is the parent class, as I just told you. All right. Now, I hope you guys understand this. So, let's do a fine example of inheritance so that you guys can understand it better. And I want you guys, after just having a look at the example, I just want you to practice it. If not along with me, then after this complete video. But it would be great if you can, practice along with it. So, yeah, we will do some hands on example now. So, let's do it. All right, so now let's do a hands-on example. Here we will be doing an example of inheritance in Java. All right, so let's start with a class. We will make a class vehicle. Now, in this class, we will make some, properties. For example, in properties, we can, declare some variables, right, and some functions also. So let's do that. String, let's say model. All right. So this is a variable that we declared, public void drive. All right. So, all right, this is a function basically, and we want to print something inside it. So what should we print? So I can drive. This is what we want to print. So we have created a variable model, and we have defined a function drive. In that function, we are just displaying a message saying I can drive. That's it. So this is what all is inside the vehicle class. Now let's move on to the next class, which is the child class of this vehicle class, that is class car extends. This is the syntax of it. We have vehicle. So car is the child class and it is extending vehicle. So vehicle is a parent class. All right. Now inside this one, again, we will make another function. Public void, let's say we'll write it show details. All right. Now, inside this function, we will display the model, right? System.out.println, right? My model is this model. So this variable is this one only, all right? So that you guys know, don't get confused. I'm just telling you right now. All right. Now this is the second class, which is the child class. All right. Now comes the main function. Sorry, the main class. Inside the main class, we will be creating the main function. Public static void main, right, string arguments. Now, first of all, here we will be creating an object of child class, and using that object, we will be assigning some values to the parent class properties. All right. So basically, this is the child class, okay, and this is the parent class. And just now I told you that this child class is extending the parent class, so it basically inherits all the properties of the parent class, right? So using the object of this child class, we will be accessing the properties of this one, which will show us that it inherits the properties of the parent class. All right, it will prove that thing basically. So car, let's name this is sedan, the object name. The class name is there, then the object name. So we are making an object of car class. All right. So car is the child class, as I told you. Just a second. Yeah, car is the child class, and we have made an object of car class. Now using this object, sedan is the object name. We will be assigning some value to the variable model. All right. So this is how we can do it. Sedan, let's say 2000. Let's name it this. All right. Now, using this object only, we will be calling the function. All right. So now just keep in mind that we are not using the parent class object. We are using the child class object, and then we are changing the value of the parent class variable. Why? Because we can do that because it inherits all these things, all these variables, this function, both. So then only we can do that. Otherwise, we can't do that, right? All right. Now sedan dot drive. This is the function of the parent class, as you can see, sedan dot drive. All right. So this is the of the child class itself. So you don't need to think much about it. But this is the parent class. So I'm just showing that using the object of the child class, you can access the members of parent class. So now let's try to run this. I hope it works. There are some errors. Let's have a look at them. Yeah, the spelling mistake. Static void main. Yeah, let's see. Just a second. Duplicate class. Okay, so we have to just delete these because these are having the similar example, so maybe that's why it is showing some errors. Let me just delete them and let's have a look at it whether it will work. Now it's working fine. So it is displaying my model is sedan 2000, which you wanted. My model is, and then this model is being, we are just assigning a value over here. And this thing, sedan dot show details, is basically printing this thing, all right. And this sedan dot drive is printing this parent class, parent function message, all right. So what we are doing is we simply made the object of child class, and using that object we assigned a value sedan 2000 to this particular variable, right. Now this variable, previously we haven't assigned anything to it, so using the object of child class we assigned a value, basically a name, sedan 2000, all right, the car's name. Then using this object only, we displayed this thing. See, sedan dot show details, we displayed model is, so it is displaying my model is sedan 2000. Then using this object, the child object only, we called the parent class function, which is drive. As you can see, parent class function drive, and it is displaying the message I can drive, and here you can see I can drive. So this basically shows what I'm trying to show you. All right. So yeah, this was about inheritance. I hope you guys understood it. If you have any doubt regarding this example, you can definitely let me know. So basically, this example that I just showed you highlights how inheritance allows the car class to reuse and extend the functionality of the vehicle class. All right. Vehicle is the parent, car is the child. Right. Now, moving on to the next topic. All right. Now, talking about types of inheritance. So there are different types of inheritance, each serving different purposes in code reuse and organization. So let's start with the first one, which is single inheritance. Now in single inheritance, a class can inherit from only one superclass. Superclass means parent class, all right? This is the simplest form of inheritance where the child class inherits all the features, that is fields and methods, from the parent class. You can take an example, just the example that we just did. It was a single inheritance only. All right. That was a fine example of single inheritance. So it is like only one class is inheriting property from its parent class. It is known as the single inheritance. All right. Now let me show you with a example. All right. So let's do an example. So this is the example of single inheritance for those who don't understand. So basically, single inheritance inherits from only one superclass. Superclass is known as the parent class, as I just told you. So this is the superclass vehicle, and this is the car, that is the child class. And basically, it is inheriting the properties of the vehicle class. For example, as you can see, it is trying to display model, which is a variable from the parent class. So if the car class is not a child of parent class, that is, if car class is not a child of vehicle class, then it can't display model, right? But now, because of the car class is the child of parent class, that is the vehicle class, that's why only it can display that. Although we haven't assigned any value to model yet, that is why it can't display anything. But it's just an example to make you guys understand what I'm trying to say right now. All right. So this is a basic example of single inheritance. Here, car inherits from vehicle. The car class has access to the drive method and model field from the vehicle. All right. So basically, yeah, that is it. All right. Now let's move on to the next inheritance, next type of inheritance, that is multi-level inheritance. All right, now multi-level inheritance. So in multi-level inheritance, a class inherits from a subclass, which in turn inherits from another class, forming a chain. It allows multiple levels of inheritance. As you can see on the screen, class C, class B, and class A. So basically, one class is inheriting properties from another class, and that class is inheriting properties from its parent class. Like it's like a relationship between a grandfather and a grandchild. So the money in terms of capital, the cars, the property which a grandfather has gained throughout his life will pass down to his parent, and the parent, the properties that he has gained will pass down to its child. So basically class C has all the excess of class B properties, and class A properties as well. And class B will have all the properties of class A. I hope you guys understand, it's basic only. Now, basically, as you can see, it is forming a chain kind of a pattern. So that's what we are talking about. So let me just show you how it looks in Java code. All right. All right. So as we can see on the screen, this is it. This is basically the multi-level inheritance. Here, the vehicle class is the parent class and car is the child class. So it is inheriting the properties. Now, electric car is the child class of car class. All right. So it is inheriting the properties of this class also. Plus, it will have the access of this class as well. All right. So basically, vehicle and this electric car has the relationship as that of grandfather and the grandchild. Simple as that. All right. Basically, this electric car inherits from car, which in turn inherits from vehicle. So electric car has access to all the methods and fields from both car and vehicle. Okay. I hope you guys understand what I'm trying to say. Now let's move on to the next inheritance, which is multiple inheritance. All right. Now coming to the multiple inheritance. So, in multiple inheritance, a class can inherit from more than one class. However, in many programming languages like this in Java, multiple inheritance is not directly allowed with classes due to ambiguity issues. Instead, you can achieve multiple inheritance using interfaces. All right. So, let me tell you what interfaces, how it would look like on the Java screen. Then I'll tell you whole thing about interface and all. All right, so this is an example of interface. As we can see on the screen, interface drivable, this is the function. Then this is a class, again this is class. Now the thing is, in interface we can't use extends, but we use implements. All right, so this is an example of multiple inheritance. Now we know that in Java, multiple inheritance is not directly allowed with classes due to ambiguity issues. So we use interfaces. And basically, for interfaces, we don't use extends, but implements is what we basically use. Now, here in this example, as you can see, electric car implements two interfaces, that is drivable and chargeable. So it must provide implementation for all the methods declared in both the interfaces. This allows electric car to inherit behaviors from multiple sources. All right. So basically in Java you can't do that, but some other languages you can do that. In Java you have to use interface, and for interface you use implements. And you can do like this. All right. Now, now there's a question there must be in your mind that why we can't do that in this one in Java. And what is interface basically? We have to know. So, all right. So, basically, interface in Java is like a blueprint for a class. So, it defines what methods a class should have, but it doesn't provide the actual code for those methods. Now, instead, the class can that uses implements, the interface must provide the code. All right. Now, think of an interface as a set of rules that different classes must follow. So basically, it helps in avoiding the ambiguity in multiple inheritance. So that is why we use it. Now Java basically doesn't allow multiple inheritance. That is, class cannot inherit from two classes because it can cause confusion. Example, if two parent class have the same method, the child class wouldn't know which one to use, right? Now instead of multiple inheritance, Java allows a class to implement multiple interfaces. So this allows confusion because interfaces don't provide method implementations, just method names they provide. All right. So this is the reason why we use interface. Now coming to the next inheritance, which is hierarchical inheritance. All right. Now the hierarchical inheritance. So in this inheritance, multiple classes inherit from a single class. Now several subclasses can extend the same parent and share its properties and methods. All right. Now have let's have a look at this example of hierarchical inheritance. All right, so as you can see on the screen, this is a fine example of hierarchical inheritance. Both car and truck inherit from the same vehicle class. They both can use the drive method and model field from vehicle. All right, so as you can see on the screen, this car is extending the vehicle, which means the car is the child class and vehicle is the parent class. And further, truck is extending from the vehicle class again. That means both car and truck have the same parent class, that is vehicle. Now, to make you guys understand, they both can use the drive method and model field, that is model variable, from the vehicle. So they both have the access. It is, you can take an example of a parent who has two child, right? So both have the properties of the parent class. All right. For example, you and your brother is inheriting properties from your father. It is simple as that. All right. So this was about the hierarchical inheritance. All right. Now coming to the next one, which is hybrid inheritance. So in hybrid inheritance, it occurs when a class inherits from more than one base class using a combination of multiple inheritance and multi-level inheritance, or you can say hierarchical inheritance also. This is generally more complex and can lead to ambiguity issues, especially in languages that don't directly support multiple inheritance. And that is Java, obviously. Now, I know this is a bit complex, but yeah, it is a mix of all the inheritance, you can say, that is multiple, multi-level, and hierarchical. So let's understand this one with the help of a fine example. All right, so as you can see on the screen, this is a fine example. So first there is a drivable interface, then class vehicle is there, and then this car class extending the vehicle and implements the drivable. So here basically the car inherits from vehicle and implements the drivable. This can be considered a hybrid form of inheritance as it combines interfaces and inheritance and class interface. All right, so I know this is a bit complex than the other interfaces, other inheritance, but this is not usually the thing that is being asked. But yeah, you must know about it because maybe in the future you can do that, right? You have to deal with it. So let me, for those who don't understand, so basically this is the, as you can see, drivable interface requires the drive method, and the vehicle class already has a drive method. Since car inherits from vehicle, it already gets the drive method from vehicle. Now the interface drivable is not adding any extra value here. Now the car class overrides, as you can see, the car class overrides the drive method from a vehicle. Even though drivable is implemented, it doesn't change anything since drive was already present. All right, so this is there. Now drivable basically ensures that any class implementing it must define drive, making the interface useful. For those who don't understand still, you can go through the example once again. So to put it in easy words, car inherits from vehicle and implements drivable. This can be considered a hybrid form of inheritance as it combines interface, inheritance, and class inheritance. All right. So, yeah, you have to go through it again so that you can grasp it in a better way. All right. So, this was about inheritance. These were some types of inheritance that you must know, and I want you to practice the examples of it as well. Now, let's move on to the next topic, which is polymorphism. All right, so polymorphism, the term polymorphism comes from the Greek word poly, which means many, and morph means form. So, in context of object oriented programming, polymorphism refers to the ability of a single method or object, or you can say operator, to take one or many different forms, to basically take different forms, right? So, in Java, polymorphisms allow objects of different classes to be treated as objects of a common superclass. It allows for a single inheritance or method to be used for different underlying forms.
Now, to put it in easy words, imagine polymorphism is like giving the same command to different things. For example, you are telling different animals to make a sound. When you say to a dog, it barks like a woof. When you say to a cat, it meows, right? And when you say to a bird, it makes a sound of tweet. Now, even though you are giving the same instructions like make a sound, each animal is responding in its own unique way. So, in programming, polymorphism works the same way. You can use the same method name, like make a sound, for different objects like dog, cat, and bird, and each object knows what to do based on its type.
All right, so let's understand polymorphism with a fine example. So here we will be doing a hands-on example of polymorphism so that you guys can understand it in a better way. So here, first of all, we will be creating a parent class which is vehicle, and then we will create a child class, and then we'll create another child class. All right, and then we will use the child classes to display some messages. All right, so let's do that. First of all, let's start with the parent class, which is class vehicle. All right, now inside this class we will be making a method or a function. All right, now we will be displaying a message, so we'll write system.out.println. So here let's say I want to write Displaying a vehicle. All right, so let's put some dots over here. Okay, energy saver mode. All right, displaying a vehicle. This is what we want to display inside this particular function, and this is the class vehicle, which is the parent class. All right, now let's create another class which is car, and this is the child class of vehicle class, so it will extend vehicle class. All right, this is the syntax. Now here also the same function would be there, that is public void show. Now in all the three classes we will be making the same function, okay, because I want to show something to you guys. Polymorphism. Okay, now system dot out dot print ln. Now here we'll write displaying a car. Okay, displaying a car, like that. So this is a car class. Now class bike. This will also extend the parent class, which is vehicle. So both bike and car class is the child class of vehicle class. Okay. Now here also the same function will make. Let me just copy paste it so that I'll save some time. All right, public void show. As we can see, we have wrote it, and by mistake I'm using capital P. P in public should be of lowercase. All right. So we have created three classes, and inside those three classes, we have made three functions or methods, each of same name. All right. Now inside the main class, that is class main, we will call the functions basically. Okay. So we'll write. Let me just create some space. Yeah. Public void main string arguments. Now inside this main class, we will create an object of car class and we'll name it my car. Okay, new car. This is how we create an object. Now using this particular object, we will be calling a function. And as we know, all the function is same. The name of all the functions is same. So how can, which function should it pick to show, right? So that is the question right now. All right, now we will be making an object of bike class. The name of this object is my bike, new bike. All right, now using this my bike class, sorry, object, we will again call a function. Now, what do you think if we will call a function show that is common in all the three classes? Using the object of car class, which function should it display? And I'm asking this question for my bike object also. You guys can take your time for that. Just have a look at the whole code. This is a vehicle class, this is a car class, and this is a bike class. So I want you guys to just write down the question, answer of the question that I've just asked. What do you think? So I hope you guys take your time. Now let me just tell you that here the show function, the show method or function whatsoever it is, so here the show function is behaving differently in different classes. All right, so when we will run it, let me just show you. So there is some error. Yeah, else should be capital. Now let's try to run this. So as we can see here, main method not found, main method not found. It is there only. All right, so it is displaying now. So I missed the static word over here. So as you can see, displaying a car here also it is saying displaying a car because by mistake we wrote like this. Now we'll run. So we have used the object of car class and we called using the object of car class. So that is why it is displaying the car class method. All right. And when we use the, object of the bike class, it is running the function of bike class. So this is basically an example you can think of polymorphism. So the thing is polymorphism happens when you use a parent class reference to refer to child class objects. Now same method show behaves differently depending on the object, right? When we use car, it displays something else. When we use bike, it displays something else. So the method is same, but it is behaving differently depending on the object. Now the vehicle reference, that is vehicle class, is the parent class of both these classes. All right. Now when with polymorphism, basically you can create a method that works for all the vehicle types without knowing whether it's a car, bike, or any future vehicle. So this is a fine example of polymorphism. All right. Now let's move on. Alright, so here we go. Now let's have a look at the types of polymorphism. One is compile time polymorphism and runtime polymorphism. So compile time polymorphism occurs when the method to be called is determined at compile time. It is also known as method overloading. This happens when two or more methods in the same class have the same name but different parameter lists. The Java compiler determines which method to invoke based on different method signatures. Overloading can occur within the same class without the need for a parent-child relationship. Now, in runtime polymorphism occurs when the method to be called is determined at runtime. It is also known as a method overriding. This happens when a subclass provides a specific implementation for a method that already is defined in its superclass. So, runtime polymorphism depends on the parent child relationships. A subclass overrides a method of its superclass, and the overridden method is invoked using a superclass reference pointing to a subclass object. Now, polymorphism can be achieved through three ways basically. First is method overriding, method overloading, and then the operator overloading. So the first one is method overriding we'll start with. So method overriding occurs when a subclass provides a specific implementation for a method that is already defined in its parent class. This basically allows the subclass to define its own version of method, and the method that gets called is determined at runtime based on the object type. So the example that we did kind of similarizes with this method overriding. Now, method overriding occurs when a subclass redefines the in the parent class with the same name and return type and the parameters. Now, this is the foundation of runtime polymorphism, and the method call is resolved at the runtime. All right. Now, let's have a look at its example. So here only we'll do the example of method overriding. All right. So class animal. All right. So class animal is there. Now inside this one, we have made an object void public sound. Now here we will be displaying a message system.out.println. Animal makes a sound. All right. Now class dog extends animal. Now here again the same method will make public void sound. Dog barks. Okay. Class main public static void main. All right. So here we are basically making an object of animal class. I hope you guys are understanding what I'm doing right now because the same thing I'm doing that I've done previously. Animal my dog. So using the same class, we have created two different objects. All right. So sorry, my bad. Here it will come dog. All right. So now after this, what we'll do is using this method, my animal, we will call this sound function, and my dog again we'll call the function. Now let's try to run this. Animal makes a sound, dog barks. As you can see, we have used the object name and those particular functions are only printing. So basically what I want you guys to just understand what I've just done. Just have a look at it, and if there is any doubt, you can just ping in the comment section and we'll resolve your queries. Just have a look at it once. Now I hope you guys have gone through this example. Now for those who haven't understand it yet, now basically animal class is the parent class. It has method sound that has that prints animal makes a sound. Now dog class inherits from animal using the extends animal, and it overrides the sound method. So instead of animal makes a sound, it prints dog barks. Now we have to understand the main method also. My animal is normal animal object. So calling my animal dot sound runs the animal class method. And my dog is a reference of type animal but actually holds a dog object. All right. So wait. This thing I've done wrong. Yeah. Now as we can see, animal makes a sound, animal makes a sound. This is the correct one. So basically my animal is a normal animal object. So my animal dot sound runs the animal class method, right? Which is correct. Now my dog is a reference of type animal, but actually holds a dog object. So this is the thing, like animal, my dog is a reference of type animal, but actually holds a dog object. When calling my dog dot sound, Java dynamically determines the method from the actual dog at runtime. This is called dynamic method dispatch. All right. Now this my animal dot sound basically is an animal object, so it calls sounds from animal. So the output is animal makes a sound. Whereas my dog.sound, even though my dog is declared as an animal, it actually points to the dog object. So since dog overrides sound, Java executes the overridden method from dog. So that is why the dog barks will be displayed. All right. So basically, dog provides its own version of sound, replacing the animal's version. All right. So yeah, that is it. Now let's have a look at the next topic, which is the next topic is method overloading. Yeah, pretty famous, right? Now, method overloading occurs when multiple methods with the same name are defined within a class, but they have different parameter lists. Now, different number of types, basically, different parameter list means different number or different types of parameters. Now, the method to be invoked is determined at compile time based on the method's signature. Now, key points to remember: method overloading allows multiple methods with the same name but different parameters. This is a form of compile time polymorphism because method resolution happens at compile time, not runtime. The method signature must differ in the number or type of parameters. All right. So now let's understand it with the help of an example. All right. Here only we'll do the example of this one, method overloading. Basically, yeah, method overloading. So first of all, we'll be creating a calculator parent object, and basically we'll be creating two classes only, that is the calculator, and then we will create a main class and we'll do the method overloading. Basically, we don't have to create child classes for that. Class calculator, this is a function public int add, where we want two variables or values, return its sum. Okay, now we will be creating another function and add with the same name, but this time the number of parameters would be different. So this time there are three parameters, as we can see, and here also we'll do the sum of these, plus b plus c. All right, so now again, but this time we'll do different data type. Now this time we have used the double data type. Previously we were using int data types. This time we have used double data type. Now in this add function, what we are going to do is double a comma double b, then return a plus b. All right. So this is a function calculator. Now here we can see we have inside this class calculator, we have created three functions and with different parameters, and one is having different data type. All right. Now in this public main, this class main, we will first of all create the main class, main function, public static void. All right, so inside this, first of all, we'll be creating a calculator object using the calculator class name. Calculator calc is the object name. The spelling mistake. Okay, so this is it. Now, wait. Now here, system.out.println. We are basically passing these two parameters, right? So now we will, understand which function will be invoked. So that is what we are going to do here. Let me just copy paste this function. Now we know double is of decimal point value, so that is why 2.5, 3.5 we are passing. So what do you think? Now you can again comment down. What do you think of this particular question? What this will display, and what this will display, and what this will display. You guys can take your time. These are the functions. Tell me. All right. So basically, as we can see on the screen, where we are passing two values, so this particular function call will automatically go to this particular function. All right. Why? Because we are passing two values, 2 and 3. It can't go over here. So this is decided at runtime. Sorry, it is decided at compile time. All right. So whenever we pass, you know, two parameters to a function, it will automatically decide the function which is having two parameters instead of three parameters, because we know that all the three functions have the same name, but they are having different types of parameters and number of parameters, right? So this particular function 2 and 3 will go over here. Second function will go over here, and third function will go over here. So let's print it. There is some error. Calculating class one cannot be applied to given types. Okay, just a second. Oh, by mistake, we have just wrote 0 in between. Yeah, let's remove it. So as you can see, 2 plus 3, 5. 2 plus 3, 5 plus 4, 9. 2.5 plus 3.5 equals 6. So this is what we are displaying right now. But don't think that we have written it serial wise. That is why it is happening. Even if I'll just remove it and keep it here. Now also if we'll display it, then it will also give us the same output, but in a different format. As we know, 2 plus 3 equals to, it will go to this first function only. Now this function will go to third function. Don't think if we have called it here, so it will go to the second function. No. 2.5, 3.5 is of data type double. So it will fetch the function. It will call the function of double data type itself. Similarly, this function is having three parameters. So it will look for the function which is having three parameters, and it will display there itself. All right. So this is how it goes. The method that is called is determined by the compiler. Hence, it is also known as compile time polymorphism. All right. So this was about method overloading. Now let's understand method over operator overloading now. So here comes the operator overloading. Operator overloading refers to the ability to redefine the behavior of operators for user defined types, such as classes. For example, in some programming languages like C++ or Python, you can redefine how operators like plus, minus, multiplication, etc. work for objects of a class. However, Java doesn't support operator overloading. In Java, you cannot define custom behavior for operators. The operators are predefined to work only for primitive types like int, double, etc., and standard classes. So yeah, this was about operator overloading. Now let's understand Java encapsulation, which is another important concept of OOPS. So encapsulation is a way of protecting the data inside an object by hiding it from the outside world. Now, instead of allowing direct access to an object data, you use methods to read and update that data. This helps to keep the data safe and ensure it is used correctly. Now, basically, what it does is basically hides the data. The data inside an object called the fields and properties is usually kept private, meaning no one can directly change it. Then it uses methods. To interact with data, we create public methods like functions that allow controlled access to the data. These are often called getter and setter methods. So getter method retrieve or read the data. Setter method modify or write the data in a controlled way. So if you want to access the private members, basically getter and setter method is used. Getter is basically used for reading the data, and setter method is used for setting or writing the data. All right. So as the name is also suggesting. Now, the control access, by using methods, you can add checks and rules like ensuring that data is always valid. So the object behaves in a safe way.
Now, to put encapsulation in easy words, think of encapsulation like a capsule or a box that keeps things safe and organized. Now, imagine you have a box with a lock, and inside the box, you keep some important items like your money or personal documents. You control who can access the box by deciding who gets the key. Now, if someone wants to use the items inside, they have to ask you, and you decide if it's okay. Now, in programming, encapsulation works the same way. A class keeps its data safe and private. If someone wants to access or change that data, they can only do using specific methods like getter or setter.
All right. So these three things are there, like hide the data, use methods, and control access is also the third point that I want to highlight. So yeah. All right. So now let's do an example of encapsulation. So let's move on. All right. So here we will be doing an example of encapsulation now. All right. So what we'll do is basically we'll create a car class, and then inside that class we'll create some functions, and then from the main function we'll be calling those functions. Okay. So I hope you guys understand what I'm trying to say right now. And so basically I hope you know the definition of it, right? So private members, we will access some of the private members using the setter and getter methods. All right. So let's start now. First of all, let's create a class car. Now here, first of all, we'll create a variable, but that variable would be private. We'll make the access modifier as private and speed. All right, so this is a private variable. No external entity can access it. All right. Now, All right, we'll create a function over here, public int get speed, because we will be accessing this function, this particular variable, eventually with the help of setter or getter methods, setter and getter methods, and for that we'll be creating a function get speed. All right, my bad. Yeah, return speed. Yeah. So basically, this is a getter method. All right. Now after this, just did. Yeah. Sorry, my bad. So this is a getter method. So now let's create another function inside this class only. So this function you can call it as a setter method also. Public void set speed. Okay. This is the name of it, and there's a parameter and speed. Now if speed is greater than equal to 0, wait, greater than equal to 0, then here we'll write this dot speed equals to speed. So ensuring that speed cannot be negative, that is why we are doing this. Okay, so speed can't be negative, so that is why we have used this if condition. Now in else block we will simply print speed can't be negative, right? Okay, now coming to the main class. So here public main function will create car, my car. Again, we are creating an object of car class. I hope these steps are just repeating, so I'm not explaining as of now because I hope I'm considering that you guys are understanding. Okay, now here we are basically calling the set speed, basically the setter function, which is used to set the speed. Okay, you can think of it like this. Now we'll be calling the getter function, my car dot get speed, and we have to do this my car dot set speed. This will show an error message if we'll set the, if we try setting a negative speed. For that we are doing this, we're passing the minus 10 function as well, minus 10 value as well. So this is a setter method, this is a get speed method. It will display something, it will set the speed. Okay, all right, so now let's run it. There is some error again. Okay, yeah, now let's try to run this. See, speed can't be negative. Obviously, speed can't be negative. We'll remove this. Now let's run. What? It is not displaying anything. I've set speed 80. My car dot set speed int speed. It is taking the speed. We are passing 80 over here, and it is greater than equal to 0. All right. So yeah, basically we forgot to print it. The main thing. So system dot out dot print ln. So here, first of all, we'll write current speed, then using the object name my car dot get speed, will call the function. All right, now let's try to run it. So as you can see, current speed 80 it is displaying. So this is an example of encapsulation. We're using the setter and getter method. We are setting the value and then the private value basically, and then we are also getting the value. So we are also basically displaying the value as well. So this is a example in which you can access the private, variables. So normally, without the setter and getter method, you can't, directly access the private members. I believe you know about it because their access specifier is private. You can't directly use it. But with the help of these getter and setter methods, getter will help to, retrieve or read the data, whereas setter method modify and write the data. So getter method will basically display it as well. All right. So this was about this encapsulation, and I believe it is pretty much clear. I've explained it while doing it. So I hope you guys understand how we can display and we can access this speed variable that was private, and but still we are displaying it. As you can see, we are displaying it. We have assigned it a value, and then we are just printing that value. So we can, in this way, we can access that private value. All right. So this was about encapsulation. Now let's understand the other concept, which is abstraction. So let's understand about abstraction. Abstraction is a fundamental concept in object oriented programming that focuses on hiding the implementation details of a class and exposing only the essential features to the user. This simplifies the complexity of the system by allowing users to interact with objects at a high level without worrying about their internal workings.
Now, to put it in easy words, think of abstraction like using a TV remote. When you press a button on the remote like volume up, you don't need to know how the remote sends signal to the TV or how the TV processes those signals to increase the volume. You just press the button and it works. The idea of abstraction is to hide all the complicated details and only show the important parts that you need to use. So in programming, abstraction works the same way. When you use a method or a function, you don't need to know the nitty gritty of how it's working behind the scenes. You just use it. For example, you might have a method named send email that sends the email. You don't need to know how the email server connects, formats message, or handles delivery. You just call the send email and it takes care of everything for you. Abstraction helps by keeping things simple and focusing only on what's necessary.
All right. Now, abstraction can be achieved in Java through abstract class and interfaces. An abstract class is a special type of class that you cannot create objects from. It can have two types of methods. First, abstract methods. These are like empty templates with no code inside them, and they must be filled in implemented by the subclasses. Whereas concrete methods, these are regular methods with complete code that can be used as they are. So I hope you understand abstract methods, they are empty. Nothing is there. There is no body. So in abstract functions, there is no body or no code inside them, and they must be filled in by the subclasses. Whereas concrete methods are like regular functions, regular methods with complete code that can be used like normal functions or normal methods. So this was about abstract class. Now let's have a look at interfaces as well. So yeah, this is interface. An interface is like a plan or a template for a class. It only contains the names of methods, not their actual code. A class uses an interface to promise that it will follow the behaviors defined in the interface. All right. So let's have a look at it with the help of an example. So now we'll do an example of abstraction, and in which there is a part of polymorphism also. So the code will demonstrate abstraction in Java using an abstract class shape. Now the shape class defines an abstract method draw which doesn't have the body. So in that way we'll create it. All right. So let's go to the editor and let's do it. All right. So first of all, abstract class. Abstract keyword we will use. This is the syntax. Abstract class, class keyword. Then the name of the class. All right. Now here the abstract function, abstract void draw. And as we know, in the abstract function there is no body or there is no code. All right. So we'll keep it as it is, as empty. We'll keep it empty. Okay. All right. Now over here. All right, here. So now here we will be creating a class circle, which will extends this shape class, abstract class. So basically circle class is extending the shape class. All right. Now here also we'll make a function draw. Yeah. But here there is something inside the body, which is a message that we want to display. So what do we want to display? I repeat. So what do we want to display is circle drawn. All right, so this was the second class. Now comes the third class, rectangle, which will extends the shape class again. So basically, circle is also extending the shape class, and rectangle is also extending the shape class. So basically, abstract class shape is the parent of both these classes. All right. Now here also void draw. Here we'll write rectangle drawn. All right. So these three classes that we have just made, now here public class main, again and again I'm doing the same thing. All right, public static void main. All right, over here we will make an object of shape class, and using that we will be doing some things. So let me tell you. So first of all, let me just do those, like shape is the name of the class, and shape is the shape with a lowercase s would be the object name. All right, so yeah. I'll explain to you guys. Just let me do first. Alright, so now let's try to run this. Okay, there's something. Yeah, by mistake we did that. Okay, void draw. Where it is? Where it is? Void draw. Cannot have a body. It is not having any body. Oh, yeah. By mistake, we use this brackets. We don't have to use the brackets also. Otherwise, it will show an error. Okay, now, yeah, semicolon. My bad. A lot of errors we are facing right now. New rectangle. Hmm. Yeah. All right. So now it, as we can see, it is running. Circle drawn, rectangle drawn. So now let me explain to you guys what I will do. I hope you understood that here this is the abstract class, and inside this abstract class there is an abstract function void draw, and you can't have the body of it. Neither you can have the brackets for that. All right. Now, as we can see, this is the circle class which is extending this shape class, and it also has the same function named draw, and it is printing circle drawn. Similarly, this rectangle class is printing rectangle drawn. All right. Now we have here what we can do is, as you can see, this code demonstrates abstraction in Java using an abstract class shape. All right. This is abstract class shape. Now the shape class defines an abstract method draw, which doesn't have a body. The subclasses circle and rectangle extend shape to provide their own implementation of draw methods, right? Now, in the main method, an object reference of type shape is created, but it is assigned to a different concrete object, circle and rectangle at runtime. Now, when shape.draw, as you can see, when shape.draw is called, the specific implementation of draw function in the respective subclass is executed, right? Now, when shape is assigned to a circle object, as we can see, when shape is assigned to a when shape is assigned to a circle object, circles draw method is called printing circle drawn. All right, this one. When shape is assigned to a rectangle object, then the method rectangles draw method is called printing rectangle drawn. All right. So this code demonstrates polymorphism by allowing the shape reference to take different forms, circle or rectangle, and call the appropriate draw method based on the actual object type. It also shows how abstraction works by defining a common structure, shape class, while leaving the details of specific shapes like draw implementation to the subclasses. All right. So yeah, this was a fine example of it. Now, I hope if you I'm assuming that most of the examples that I just discussed you guys understood, but if it is there something that you have not understood, you can just just revert back to this video and understand it again and try that. When you'll try that, you will understand many things. Just by looking at the code, somebody is doing the code, you won't understand anything. Just understand it and then try to do it yourself as well. You will gain the knowledge by trying it yourself. That's the main thing that you should focus on right now. All right, so this was about abstraction. So yeah, we have covered inheritance, polymorphism, encapsulation to abstraction as well. Everything we just cleared. I want to practice each of these examples on your own as well.
Now let me ask you this. If you are eager to dive deeper into Java and full stack software development, check out upGrad and IIITB's Executive PG program in software development, specialization in full stack development. This program is tailored for working professionals and offers 500 plus hours of rigorous training, over 9 projects and assignments, IIITB alumni status. So don't wait, click the link in the description and kickstart your journey today. Also, we believe that everyone has a unique journey to success, and sometimes all it takes is a right guidance to unlock your full potential. Our expert career advisors are here to help you find the perfect path for you. So don't miss this opportunity to invest in your future. Click the link below to book your free counseling session and let's start building the career you have always dreamed of. From inheritance, polymorphism, and encapsulation to abstraction, each concept plays a critical role in improving your coding efficiency. So in this video, we have covered all of these concepts in detail with hands-on examples. Now, I want you to practice all these concepts by yourself also. Now, if you have got any questions, drop a comment and we will be happy to help. And hey, don't forget to like, share and subscribe for more career insights.